Okay. First of all, I would like to go back to this code I promised to clarify for you from the other day, on Monday. Insertion sort. Let's do that very quickly because it's really quite a fundamental algorithm for you to understand. Let's do it properly. Okay? For insertion sort, we already know it's going to be a quadratic algorithm. It's going to be n squared. But let's just trace the program again. It's not as complicated as you might think. The tricky part really is this part of the code over here. If you look at that, inside a while loop, you're trying to do kind of like a shifting things around over here. Like assigning j minus 1, the one that's a little bit to the left, to the one that's to the right, j. Okay, we'll see exactly how this is going to happen. If you review the way you do your birthday book remove method, that's exactly what's going to happen over there. Okay, but let's have a look. As we said before, the way you understand sorting for insertion sort, selection sort, you started with something that's completely unsorted to begin with. Okay? And then let's have a look at the outer loop. If you look at the outer loop, I is going to start with the value 1. Okay? And we know that in this particular case, n, which is the size of the array, is 4. Okay? And then if you look at the just outer loop, how many iterations are we going to run for the outer loop? If you look at the values over here. Starting from 1, and it can go all the way up to, by excluding 4. So that means we got 3 iterations, right? Okay, just get that clear first. So that means for I value is going to be 1, and then I'll use different color to show you. 1, and then 2, and then 3. Okay, 3 different iterations. So now we're going to see exactly what's going to happen within each iteration for the outer loop. There's going to be several iterations for the inner loop. That's how the nested loop is going to work. Now, when we go to the first line, so now we talk about the very first iteration for the outer loop. The very first line in the body of the outer loop is going to be current, which is some value we want to insert into the green area. In the beginning, you don't see any green area. It's simply just empty in the beginning. And then it's simply going to be AI over here. And at the moment, what's AI? AI is going to be A1, right? What's A1? A1 is simply just 1 over here, right? I'll just put 1. So current is simply just 1 to begin with, okay? And then we go to the next line, and then we initialize the loop counter for the second, we initialize the second loop counter, which is j. J is going to be assigned to the current value of I, which is 1. So that means you can think about it at the moment, I is pointing to here, and j is also pointing to here, both of them. Okay? And then for this while loop over here, I tried to explain to you on Monday how you can think of it. I'll just briefly mention, you can review the notes. The way for you to think about it is the Boolean condition over here, j larger than 0 and aj minus 1 larger than current, is the condition under which you're going to stay in the loop. But at the same time, you can think about under what circumstances am I going to exit from the loop, which is going to be logical negation of that. So you can refer to the part of the notes on Monday. I'm going to skip that part just for today. Okay, so now let's have a look. Is this going to be satisfied at the first time? Okay, at the moment, j is going to be just 1. Okay, by the way, current is going to be just A1, which is 1. So that means we're talking about this is the current. Okay, that's a value. Basically, we are thinking about how we can insert 1 into the green area. That's basically what we're talking about. Intuitively, let's predict what's going to happen. 1 should really occur to the left of 3. Agree? So that means somehow we have swapped them. Okay, somehow. But we'll see exactly how the swap is going to happen. And then we have j being 1. 1 larger than 0 is true. So left-hand side is fine. What about aj minus 1? What's aj minus 1 in this case? J is here, so that means j minus 1 is over here, right? So aj minus 1 is 3. So that means 3 larger than current, which is 1, is true. That means we have to go into the loop body over here and do something, okay? So this is the trickier part, okay? So now if you look at this line over here, we say aj is assigned to aj minus 1. Let's just write it out explicitly. J currently is simply just 1. So that means we talk about A1 is assigned to A, 1 minus 1, 0. A1 is assigned to A0. That means we're going to say, let me just put it here. So that's going to be the resulting array over here. I'll put it here. So now we begin with 3, 1, 4, and 2. Okay? So now we say A1 is assigned to A0. So what's going to happen? A1 is assigned to A0. That means this part here is going to be overwritten by 3. Agree? At the moment, it doesn't make sense because now that means the value of 1 is gone. But remember, 1 was stored as the value for current, so it's not gone completely yet. That's why we're going to use it just in a bit. And then after this, we're going to say j minus minus. That means j is going to move from here into here, right? That's what we're going to do. So now j minus minus, after which j will become 0. So now we're going to go back to the loop again, and let's see what happened. If we go back to the loop again, j is now 0. J is being 0. 0 larger than 0 is false. And false is going to make the conjunction false anyway. So that means we are done with the inner loop. Okay? So that means after that, we'll go to line number 8. And what is line number 8 going to do? It's going to make things back to the sensible stage. So now we say aj, j at the moment is simply 0. So a0 is assigned to the current value, which is the one we just stored previously. Okay? So now what we do is, over here, it's going to be a0 is assigned to whatever current value it is, which is 1. So that means a0 over here is going to be 1. So again, that's exactly how we do the swap. So now let's think about what's really happening after this. Oh, let me be more clear. So the array over here is after line number 7, and this is the array that we have eventually after line number 8. So that means we got over here 1, 3, and then 4, 2, like this. That's the eventual array. So this is the excuse me. So this is the array after line number 8. So what we have done is we have sorted just the first 2 slots of the array. So 1 followed by 3. Okay? So now here comes what we got confused on Monday. Now if we go back to the outer loop, let me use the blue. If we go back here to the outer loop, we know that I is going to be incremented from 1, the initial value, into 2. So that means now the current value for I will just be 2. That means I is now going to point to over here, right? Used to be pointing to index 1, but now for the second iteration, it's going to point to index 2. So what does that mean? That means over here, if you think about it, I is now being 2. We want to insert number 4 into the right spot so that we can grow the green area for exactly 1 element, right? Now, for this one, hopefully it's very intuitive for you because you can see that over here, this 4 is already larger than the 3, which is a maximum in the green area. So this, we don't have to go any further, right? If you try this, let me be more precise for you. If you go inside to this line over here again, you will see that the current is simply going to be AI. I has been incremented from 1 to 2. What's A2? A2 over here should be just 4. Okay, A2 is simply just 4. So 4 is the element we'd like to insert into green area to grow it by just size 1. Okay, and then we go into this line over here. J is assigned to I. And I is currently just 2, right? So J is now going to be 2. And then this while loop here will be quite easy for this particular case. Why? Because you can see that over here, J being 2 larger than 0 is true. What about this? When I say A, J minus 1 larger than current, let's have a look. J is basically 2 at the moment. A2 minus 1 would be A1. What's A1? A1 is 3. Thank you. And then when I say larger than current, current is 4. 3 larger than 4 is false. That means this evaluation here is going to be false. That means we don't bother to go inside. And we're already done. Nothing to do. Okay? So after the second iteration, what we're going to have is something like this. I'll draw it over here. What we're going to have is exactly 1, 3, and 4, followed by 2. So conceptually, you can think about we have grown the green area by exactly 1 element. So 4 doesn't have to go anywhere in the middle, because 4 is already larger than the maximum in the green, which is 3. Okay, finally, now you can imagine that if we try to go for this last iteration, if we go back to the outer loop again, I will be incremented from 2 to 3. So that means the value for I would now be 3. That means we're considering inserting this particular element, right? So now we are thinking about how to insert 2 into this green area, right? That's what we are thinking about. Okay? So now one more thing to mention before I leave it for you to think about. So now what's going to be the current? If you look at line number 3 again, current over here is going to be A at position I. I is currently just 2. Oh, sorry, I is going to be 3. A3, and then it's going to be just 2. That means we're inserting 2 to the right spot into the green area, right? So now, rather than going over the while loop for you, I would like you to go over that yourself. I'm just going to show you how it's going to change in the diagram very quickly, okay? So now what I would do is, first of all, I'm going to draw exactly the diagram over here for you and see how the things are going to be shifted. So now I'm talking about the last iteration over here. So we started with 1, 3, 4, and 2. Okay, that's how we started with. And then we started with, and then this is a green area from the before. So now how do we insert 2 into the right spot? This is how you can see. Is 2 larger than 4? No. If that's not, we're going to shift 4 into 2. Okay? Now, we look at, is 2 larger than 3? No. So shift 3 into here. Now, is 2 larger than 1? Yes. So we put 2 over here. Okay? That's what's going to happen. Of course, the trick really is you have to really follow exactly how the while loop is executed. Okay? Guys, I hope that's clear. Okay? Good. That's about insertion sort. And I promise, when we talk about recursion, I think we'll have enough time to cover 2 kinds of sorting. I want to teach you about merge sort and also quick sort. Both of them will be n log n. I think that will prepare you well for 2011. Okay, that's what we'll do a little bit later. Okay, after this, let's go back to call by value. Okay, I would like to just review that very quickly for you, and then we're going to talk about aggregation and composition today and also next Monday. Because for your lab number 4, you do need a copy constructor. I hope I can at least get to it a little bit, but if not, then we'll definitely finish that on Monday. Okay, for call by value, the only thing you have to remember is when you pass an argument in a method call, only a copy of the value of the argument is made to the parameter. Okay, let's see that's the principle. But let's see for different cases. So now I want you to compare 3 cases. For case number 1, this is the method we are talking about, and the parameter type is integer, int, which is primitive, right? Case number 2. Over here, this is the method we are talking about, and the type of the parameter is point, which is reference type, okay? However, for reference type, things get more interesting, because for reference type, we do have a phenomenon called aliasing, which we did quite a bit in the beginning of the semester, but we'll see a lot today as well when we talk about aggregation composition. And for the second case, for reference type, we also got a reference type parameter. Okay, so let's consider these 3 cases and see how things will work. Okay, let's see the first case, which is very easy. We did it already on Monday, but let's just review. So now this is what I want to do. If you look at the test code over here, let's go over line by line. Line number 1, I'm simply just creating a utility objects. Okay, that one I can just ignore. That's easy to imagine. And then I declare an integer, primitive integer variable. Let's say I is like a box over here, which contains a value called 10. Okay, so far so good. And then let's not worry about line number 5 just yet. Okay, let's look at directly line number 6. I'm trying to call reassign int with I. So now you can see that I over here is the arguments. That's the actual input value that we pass to this method call. what we have to do is to look at the definition of that particular method. So now we know that the context object here is of type utility. That means we should go to the util class over here and then look at this method over here. And we know that the type of the method is simply int, right? So implicitly, what Java will do implicitly, I'll emphasize it's really implicitly. You don't need to do it by yourself. Implicitly, we have j is assigned to I. Okay? So what does that really mean when I say j is assigned to I? In the case of primitive type, you simply copy the value over, right? Good. So j is over here, copy the value over, so you got 10. So now I got 2 copies of the value 10. Now, the question is, after executing the method call at line number 6, are we going to change the value for I? Given that in the body of the method being called, we say j is assigned to j plus 1. That's the question. Are we going to change the value of I, given that we're going to change the value of j? Okay? If you look at over here, if I change the value of j, that means I'm only changing the box over here from 10 into 11. Whereas this box here over here is unaffected. That is why you will see assert true I being equal to 10 before the method call, and also assert true I still equal to 10 after the method call. So the value of I is unaffected. Okay? Make sense? Any questions about this? Yes? If I didn't put the assert true?
In line number 7.
Line number 7, if I didn't put it?
If you didn't put that there, would I still remain?
Oh, you will still be. Remember, assertion doesn't intend to change anything. We're just trying to assert to say something that we expect to be true is really true. Otherwise, we'll actually have some assertion failure. Okay, guys, please. Okay, yeah.
What happened to J afterwards? Does it just like...
Good question. What happened to J? So thinking this way, if you think about the variable j over here, what's really the scope? Scope of j. If you think about the scope of j is only, let me use green to annotate, the scope of j is only within this particular method, which means we only try to declare j when we first try to execute this method. As soon as the execution for this method is done, j is gone. Nobody else can actually refer to it, right? That's actually what it means, okay? Okay, any other questions about this? Okay. Sorry about that. Okay, so now, let's now look at the second case. Given that we understand the primitive type, so now what we're gonna understand is about the reference type. The principle is still the same. We only try to copy the value of the arguments. But now, if the argument happens to be a reference type, what does that argument really store? It doesn't store the value of the object itself. It only stores the address of the object, right? That's the only thing that's different. Everything else remains the same. Okay? And remember, every time when you're trying to copy the address of some objects, that means you are introducing aliasing. That's why we got 2 subcases for call by value for reference type. Let's see. So now we're talking about this particular method over here. This method over here. So we have reassign ref. Okay, that's where we ended up with on Wednesday, on Monday, kind of in a rush. Let's do it properly. So now what we want to do is we call this method over here, but before that, let's see what we have to set up. Okay, let's see exactly what's going to happen. This line over here, just util. Let's not worry about it. Okay. Now for line number 4. We are creating a new point object called P. And then we have, I would say, point over here, which got attributes x and y. And then x is going to be 3, y is going to be 4. 3 and 4. Okay, that's what's going to happen after line number 4. And what about line number 5? Let me include this into the picture as well. That's how we do the testing. Basically, what we want to assert is, after this method call over here, P is still going to point to the point object here. Exactly that. It's not going to be reassigned to anything else. Okay, so now I'm going to put a special color here. I would say this is a ref of P before. So it's going to be ref of P before. Okay, it's going to point to wherever P is pointing to, right? That's how we do the assignment over here. So far, so good? Okay, that's what line number 5 will do. Let's have a look at line number 6. When we try to execute line number 6, we're going to apply the same principle for call by value. How do we apply that? Okay, think about what the implicit assignment that's going to be done. I'm trying to pass the argument value for P, so this is the arguments. And then, what's the corresponding formal parameter? Look at the corresponding method. The context object is of type util. So go to the util class over here and look at this particular method, which is reassign ref. And then you will see that this is the type of the parameter. And the variable name for the parameter is simply just Q. And what's the implicit assignment we're trying to do? P assigned to Q or Q is assigned to P? Q assigned to P, right? Okay, make sure you got it right. Very good. Implicitly, again, I emphasize implicitly, which means you never do that by yourself. Q is assigned to P. So now, the next question is, how do we change the picture? So that means Q over here is going to point to wherever P is pointing to, like that. Because Q is not going to have the same address that is stored in P. So now, the question is, conceptually, after executing this method over here, let's see what the intention for the method is. The intention seems to be, we want to do some reassignments for Q. We want to say Q is assigned to some new points, which is created over here. Let's just draw it. Okay? I'm going to use another color over here. Let's say MP over here is pointing to a new point object over here. And then it's just going to be X and Y, 6 and 8, right? 6 and 8, MP. What we intend to do is we're going to say Q is assigned to MP, right? Now the question is, when we try to reassign Q to MP, would it at the same time also reassign P to MP as well? That's the question. Hopefully that's quite obvious in the diagram, right? Let's see exactly why it would not be the case. When we say Q is going to be reassigned to MP, what we are trying to do is Q, rather than pointing to over here, is going to point to wherever MP is pointing to. At the same time, we are not changing what P is pointing to, right? Good. So that means after line number 6, P is still pointing to the same object that used to point before. So that is why you try to do this comparison over here. So this comparison is really the key. So this one shows you P is still pointing to wherever it used to point to before the method call. Okay? So that means P is still pointing to the same object as ref of P before. Okay? P is not reassigned. Okay? The only, diagrammatically, the only arrow that we try to redraw is only the Q arrow, but not P. Okay? Again, that's call by value. Any question about the first case for call by value for reference type? So lesson learned from this particular example is you cannot reassign the argument reference to another object. You cannot reassign. Okay, that's lesson learned. But now the next question. However, can you actually change the object that is being pointed to by the argument address? Let me repeat. Can you actually change the point objects that is being pointed to by the argument address? Well, actually you can, based on what we learned before about aliasing. As long as you get the address of the objects, you can definitely do something with it. Okay, let's see exactly how it's going to work. So we've got something very similar for you in the next one. That's a case number 3. So now we look at another method over here called change by ref. Okay, and also change by reference. Okay, when I say change by reference, simply means there's an aliasing over there. So we can simply call some method. Let's see exactly how we can do it. Okay, what I would do is, let me just try to go from scratch. Okay, so it's complete. Let's go to this line over here. When I say point P, let me use blue maybe, that would be better. When I say point P, it's a new object. So that means P is now pointing to a new point object over here where X and Y are simply 3 and 4. Okay, that's what we got. And then we try to have this reference just for us to do the assertion for checking, right? Let me just use a different color for that. And this one over here is simply ref of P before. Okay, that's what we have. Now, let's now try to make the method call. And let's see what's going to happen. Again, when we try to make this method call here, it's going to be called by value, right? That means we're going to make a copy of this P over here and store that into the corresponding parameter. So that means implicitly, we're going to say Q is assigned to P. Agree? Implicitly, okay? So what I will do is I'll use green over here. That means Q is going to point to wherever P is pointing to, right? At this point, implicitly. So now, what's going to happen if we try to execute the two lines over here? You can see we are not trying to do anything like a Q is assigned to something else, because we know that that's not going to affect anything about P. But what if we try to say Q dot move horizontally by 3 and Q dot move vertically by 4? Right? Let's see exactly what's going to happen. If I say Q dot move horizontally by 3, okay? The context object is really important over here, okay? So I'll leave that in just a moment. And now, when you say move horizontally, which is defined over here, move horizontally over here, right? That's defined in the point class. And then over here, 3 is, again, called by value, right? For the primitive type. You can think about x is simply assigned to 3. Okay, I'll just, for convenience, I'm going to say 3 over here. And then x is also going to be assigned to 3. But now what's this? Context object, which is q, right? That means q.x is going to be incremented by 3. And what's q.x? If you try to follow the arrow, q.x really is, over here, q is referring to this particular object over here. .x is going to give you this attribute over here, right? q.x is incremented by 3. That means we're going to change that from 3 to 6. Now the question is, does that somehow indirectly modify the object that's being pointed to by P at the same time? Right, because we got aliasing, right? Because P and Q, they're referring to the same objects. So it doesn't matter which, okay, again, P and Q are aliases of the same objects. Okay, that's point number 1. Point number 2, to modify that objects, so this is the object I'm talking about. To modify that object there, you can use P or Q as context objects, right? Over here, we're trying to use Q as a context object to change it. Okay. Now let's go to the next line. When I say Q.move vertically, right? I'm going to do the same tracing. When I say Q.move vertically, and now the value is going to be 4, so Y will be 4, Y will be 4 over here. And now what's this? This will be the context object, which is Q. And Q is this object over here. Q is referring to this object again. And Q.y is over here. Q.y is over here and incremented by 4. So that should go from 4 to 8. Okay, that's what we have. So that means so there are actually quite a few things that actually happened when we try to make this particular method call, as you can see, right? When we try to make this method call over here, when we are passing the address that is stored in P, the address is made for a copy and stored into Q. And we're using the address that is stored into Q to make some method call. And that's actually modifying the same objects, okay, P and Q. Okay, so now that's why when you say assert true, P is still pointing to the same objects. P is not reassigned. Apparently, yes, because now you can see that over here, P and ref of P before, they're still pointing to the same objects, no problem. However, if now you try to do the following assertion, when you say P.x and P.y, before this method call over here, P.x used to be 3, and P.y used to be 4, used to be the case, right? That's how we created the object to begin with. But after this method call, we actually got P.x being 6 and P.y being 8 because we are referring to the same objects. Okay? Again, similar question as before. what's going to happen to Q after the method call? Q will be garbage collected. It will simply be gone. Okay. Okay, any question about this? Call by value, okay? There's a single principle, but that will be applied to both primitive type and reference type. Okay, guys, any questions? Okay, we're gonna see even more examples like this when we talk about aggregation composition. Okay, things will get not really complicated, but I think I just try to build up more sophisticated cases for you. Okay, let's now go back to the slides. So everything we have covered, so go over them, and let's move on to aggregation composition. Okay, everything up to now we have covered, all right? So the way I draw the diagram over here on the slide, just like how I drew on the iPad, okay? But if you want to see the thinking process, maybe review the video. Okay, so now I would like to talk about two notions. One is called aggregation, the other one is called composition. So the difference between the two is easy. For aggregation, you allow aliasing or sharing to happen, which means there might be different objects that point to the, there might be two variables that store addresses of the same object. They're pointing to the same thing. So aliasing is actually allowed. On the other hand, for composition, it's go to one extreme. That means no sharing is allowed. Whenever you see anything that's shared between two objects, two references, that means it's violating composition. So we'll see example. I just want to make a summary first before we even talk about it. Before we talk about, before you see exactly how you can program them, let's see from the modeling point of view, what can be the use cases, what can be the applications. Let's have a look. Okay, so now let's define some terminology over here. We have something called container. Container simply means an object that contains another, okay? And then containee, something that's being contained. Okay, just two words that you should really get used to. And then, for example, one case for container and containee is each course has a faculty member as its instructor. Can you see from this English sentence here who is container? The course or the faculty member? Course, right? Because over here, basically you're trying to say course contains a faculty member as its instructor. Or more like a Java. In each course class, you want to declare an attribute called instructor of type faculty member. Okay? That's how you see it. Okay, so container will be course and the containee will be a faculty. Okay, good. And what about this case over here? I say each student is registered in a list of courses. And also each faculty member teaches a list of courses. Can you see any container? How many containers do you see over here? One? If you think one, which one? So if you say list of courses is the container, let's follow your logic. If you think the list of courses is a container, what do they contain? They contain the students or they contain the faculty member. So what are the classes we're talking about over here? Basically, we talk about students over here. Let's just identify the classes. We have students, and also we have course, and also we have faculty member. We got these three actors over here. So now, would you say, let's say students and course. Would you say student is a container or course is a container? Course is a container? Or, well, when you say container, right, that means container contains something, right? So do you say each student must have an attribute? Well, let's put it this way. If I say the following, I can say the students is actually a class, and each student class declared an attributes of type maybe list or array. And then each element in the array is of type course, right? Does that make sense? That means a container being students contains a list of courses, okay? What about the next one? When I say each faculty member teaches a list of courses, kind of similar, right? So that means each faculty class also declares an attributes, maybe call that maybe courses as well. And then it's going to be all the courses that the faculty member teach. Okay? It's a little bit abstract, but what I'm trying to show you is sometimes you might be just given English description to implement, but you don't necessarily always be given the Java classes. Okay? Okay, good idea. So now containee, container will be student and faculty, containee will be course. The only difference between these two examples is the following. When I say the course contains faculty, how many faculty does it contain? Just one, because each course has exactly one instructor, just one. It's about the size of the containee. What about the size of the container, like how many it will contain? What about here? Does students contain only a single course? Not really, right? Since we say a list of courses. So that's the only difference, right? So whenever we talk container, containees, you got to worry about the size, like how many containees it will contain, okay? Okay, so for example, you would say 2030 is taught by Jim, and also it can be taught by Tom. Now, I want you to see one thing here. Imagine this. Of course, we'll see example in just a moment. When I say the course EECS2030 is a course object somewhere at the runtime, and then I say that Jim is a student object, and Tom is a faculty object. Jim and Tom, they're simply different objects, even different types. But now they're kind of sharing the same objects, right? Course. That means maybe for Jim over here, one of the attributes for Jim is simply an array of courses. And then one of the array elements points to 2030 objects. At the same time, for Tom being a faculty object, also has an attribute being array of courses. One of its elements also points to the same 2030 objects. So now we do have some sharing. Okay? So this is the typical case for aggregation, which means somehow you got sharing of the same objects by other objects. So that's aggregation. Question, go ahead. Yeah.
They each have like an array called list of courses.
Yep.
And they might be pointing to the same thing as the EECS2030.
Correct.
But they're not going to be the same address.
Okay. You know what? To clarify, how about we draw something very quickly? Okay. I'll sketch a bit. What about, let's say, Tom is a faculty. I'll just put F over here. Is a faculty. And one of its attributes is simply courses. I'll say CS, which is going to be the list of courses that Tom is currently teaching. There's going to be some array of courses and like that. Okay, and then Jim is going to be pointing to a student's object over here, and one of its attributes, let's say also courses, right? Courses over here, and then it's pointing to an array of courses. Let's say this. If Tom is currently Jim's students in 2030, that means they share the same course, right? That means we have the following phenomenon. Let me use a different color here. So that means we got a course. Maybe I'll call that this course object EECS2030. It's a course object over here, right? Let me say EECS2030. So now what we have is maybe the second course that Tom is teaching is EECS2030. At the same time, one of the courses for Jim that's currently registered in is also EECS2030. So now we do have some sharing. How do you do some assert in JUnit to assert there's really a sharing going on? How do we assert? How do I assert the fact that Jim and Tom, they are really sharing the same green objects being course? Say that again? You may compare the address. Yes, I agree. And in this case, can you say assert equals? When you say assert equals, you got to be careful, right? Because when remember, you may have to review a little bit your notes for equals. When I say assert equals over here, something and something, this does not necessarily compare the addresses, right, of the two objects, because by default it's going to call this dot equals this. In which case, if the equals method is already overridden, it's not going to compare the addresses. So this is not the way to go. Okay? What we should do is something like this. I'll show you one example. In this case, we want to say basically this particular address is the same as this address over here. So how do we do that? You can say, for example, one thing to say is assert true, and then we want to say the two addresses are the same. How do I refer to this object from Tom's point of view. Tom dot the what? Courses, thank you. And then go to element number 1. Okay, that's basically talking about this index here. That is the same address as Jim. Also, let's say also courses at position 2. So this assertion should be true. That means we do have sharing. So that's the essence for aggregation, which means down to the object structure at the runtime, there might be some sharing or aliasing going on. So when I say sharing, is you can use that exchangeably with sharing and aliasing. You can use them exchangeably. Yes.
I'm wrong, but it feels like even if the value of those bases are the same as well, not the addresses.
I see what you mean. Yeah, you're right. Yeah, but aggregation talks about addresses because we talk about sharing. So I would say if you want to judge to see if this is a case for aggregation, you want to see if there's any sharing about the equals, right? Okay, one more thing about the usefulness for aggregation. So now, if I want to say I want to rename the course from EECS2030 to EECS maybe 2040, for example, right? Let's say for some reason. In this case, how many lines do I have to write? Do I have to say something like, for example, do I have to say tom.cs1 dot maybe set the name of the course to be maybe EECS 2040? Just once, right? Because whichever way you go, you can see now currently there are 3 different paths for me. I can either go for this path over here, I can go for this path, or I can go for this path. All the 3 paths refer to the same objects. Okay, so you can just choose either one of them and change the name of the course. Okay. But I can think about the register office got the access to the EECS 2030. So if they modify the name of the course, it's going to be visible to both the faculty and the students. Okay, that's more like a real world, real life example. But it's only a sketch. We'll see more concrete code in a moment. Now, since we talk about runtime structure, let's talk about, before we give you an example for composition, how is composition going to be different from aggregation? The principle is easy. If you allowed aliasing or sharing to happen, it's aggregation. If you don't allow that, that means all the runtime structure must be completely independent. That's composition. Okay? Let's see some example. Let's go back to the slides and let's see. Okay, one thing to note. Let's say this. Also, another thing about composition, another thing about aggregation is, since we share the containees, right? Since now the faculty and also the student, they share the same course. So now let's say, at the moment, let's say now it's December, around the Christmas time. So EECS 2030 for 2018 is gone to history, right? That means somehow we have to delete the objects, right? If we want to delete the objects, so imagine what's going to happen here. That means we are simply just going to say this object over here is going to be garbage collected by the system. At the same time, do we also have to garbage collect the container, which is Tom and Jim? Do we have to? No, it doesn't make real sense, right? That means whenever you try to delete one of the containees that's being shared, you just delete the containee themselves. You don't have to worry about container because they're only just sharing. If the shared object is gone, the container still exists. Okay, that's one thing to know. However, for composition, if you try to delete the containees, you got to delete the container as well. Okay, that's kind of something you want to keep in mind. Okay. Okay, let's see one example here. So now let's talk about file system. I'll just illustrate to you. Okay. So now let's say this. If you look at my desktop here, I do have a directory called D, right? And D is more like a container. And D has 3 text files, F1, F2, and F3. Okay? So now, why this should be a composition rather than a aggregation? Think about, can there be any two directories that share the same file? Let's say, for example, what I really meant is a very restrictive case. Let's say this. If I just create another file over here, let's say D2, okay? I got two directories. Is it possible for me to say, now I got D2 over here, I open that at one end, and also I got D over here at the other end, okay? D and D2. Is it possible for me to add a file into here such that it is sharing the F1 over here as well? Well, it's not really possible, right? Unless you make a copy to it. Okay, agree? So now, that's point number one. What about I try the following? If I try to delete the container, what's going to happen? Am I deleting all the containing files as well? I am, right? As soon as I say delete, then, of course, F1, F2, F3 also throw to the garbage bin. Okay? That's just one simple case for composition, which means whenever you try to delete a container, all the containees cannot exist without a container. Okay? They must coexist together. Okay? That's the kind of principle. Okay, so now if you go back to the slides over here, the container will be directory or folder, and containee will be file. Okay, and then over here we want to say if you delete a container, you must delete the containees as well. So they must coexist together. Okay. Okay, any questions about this? Okay, any question about aggregation composition? We haven't seen it in code yet. I just want to give you some conceptual ideas. Okay, again, the principle is if you allow any sharing, it is aggregation. If you don't allow anything that can be shared, that's composition. Okay, let's see exactly how we can implement this. Okay. Also, this certain diagram, I would like you to at least know how to read the diagram. Okay, let's have a look. So now let's go to the simple case for container and containee. Okay, I will just go to the code over here, and then we also got to draw some diagram. So case number one, basically. So what's so funny? All right. Okay, so now let's have a look at the aggregation over here. Let's see the first case. I would like you to look at the diagram over here. Okay, and then let me draw that on the iPad and I'll show it to you. Okay, we got a course over here, and also we got faculty. Okay. Okay, so now, you use a rectangle box to denote the class. We got a class called course, and also we have a class called faculty. Okay, so now what we do is we have an arrow in between. We have a line between them like this. Okay, and then we are saying that a course simply contains a faculty being its instructor. That's why we put an instructor over here, like that. Okay, a course being the container contains a faculty being its instructor. That's how you read it. It's not too hard. You just have to remember the order. Okay. One more thing to show you, because we have to distinguish between aggregation and composition. So if you go back to the diagram over here, notice that there's an empty diamond over here. If you got an empty diamond, that means sharing is actually allowed. I'll put it over here. So that means you have something like this. So over here, and then empty diamond over here. Okay, so this diamond here simply tells you it's aggregation. Aggregation simply means if you have to delete the container over here, you don't have to delete the containee. Okay, so the empty diamond is the key to see whether that's aggregation or composition. Okay. Anyway, just about diagram. You wouldn't be expected to draw the diagram, but you are expected to read the diagram. Okay, so all you got to read is course being the container contains a faculty being its instructor. And since we got an empty diamond here, so that's aggregation. Sharing is allowed. Okay? So now let's see this simple case over here. And then we try to draw, again, it's really the exercise that we try to do in week number 1 and 2. We just got to draw a diagram, visualize what's happening. So let's do it all together. So let's go over the classes we have. Let's say we have one class called course over here, and then we got title, we got prof, and also we have a constructor initializing the title, and also we can set a prof, and also we can get a prof. And one thing to remind you about, you can see now the parameter type is reference type. So exercise for you, we may just go over that when we trace the code. It's call by value for the reference type, right? And another class to look at would be faculty over here. And then each faculty has a name, and also they have a constructor over here. Also you can set the name, and also you can get their name. Very standard methods. Okay, now let's just, as a warm-up, let's see how the simple aggregation case, which means a container only contains a single containee, only a single one. Let's see that. Let's draw that together. Okay, the first two lines are really easy. Just initialize 2030 and 3311. So I'll do that quickly. So EECS2030 is now pointing to a course object. I'll say C for short. And for each course, we have the title and we have prof, right? So now, for the title, I would just say 2030 over here. And also we got EECS3311, which is also pointing to a course objects. And then the title over here should be, I'll just say 3311, but it should be software design. I'll say 3311. Okay, so far so good. And also we have a prof field. I'll use bread prof over here. Initially, you can see the constructor is not trying to set the prof. What will be its value initially? If the object reference is not initialized, no. Initially, it's simply just no. Okay, that's after the first two lines. Any questions? Okay. And now let's try to basically create two objects over here. What we will do is, let's say over here, let's do, blue would be better. Let's create a faculty object over here. So what we'll do is we'll say prof is now pointing to a new faculty object. I'll put F over here. Each faculty has a name, just a name. And then I'll just put the name over here. So name is Jackie over here, like that. And then when we say now for the next two lines, I'll just review very quickly call by value very quickly. Okay. Now these two lines are really important. This line here and this line here. Okay, these two lines. What do they do? What they will do is over here, let's say the first one. When I put prof over here, that's the arguments, right? And what's the corresponding formal parameter? It should be for the setProf method, which is over here, right? SetProf. And the formal parameter is simply just prof. Okay, so don't get really confused. The prof over here is really the prof that's over here. And the prof over here is simply just they belong to another scope. Okay. So what we'll do is, let me just use let me use a proper color so to make sure you're okay. So let me just say this prof over here is simply just a pink. Okay. And then what we have over here is we're gonna have the prof over here is also pointing to the same faculty member, right? That's what we are trying to do. Make sense? Okay. So that means over here, after this, we'll say this.prof is assigned to prof. What's this? Well, this is the context object over here, which is EECS2030. So EECS2030 is referring to this object over here. And then we say this.prof, which is referring to this attribute over here, right? And then rather than pointing to null, it is going to point to this faculty objects. That's what it will do. Make sense? Anyone not following? We're okay? Okay. Now, next line. What about this one here? That said prof. Since it's the same argument value being passed, that means we're going to do the same process. So now, for EECS3311, which is this object over here, so now the prof attribute, rather than pointing to over here, is now going to point to the same faculty objects over here, right? So now we do have aliasing. So what exactly is the aliasing? We'll see. If you see the next line over there, EECS2030.getProf equals EECS3311.getProf, right? So over here we have EECS2030 over here. When I say getProf, what would I get? Well, think about which arrow it is going to follow. Okay? So if you think about getProf over here, that's the method we're trying to call. And then we simply say this.prof. What's this? This is EECS2030. EECS2030. And if you follow through EECS2030.prof, will be referring to this pointer over here, right? That's what is going to happen. So that means it's going to follow this pointer over here for that. On the other hand, let's look at the next one. If I say EECS3311, so now the context object is different. That means calling the same method over here with a different context objects. So now what's this? This is EECS3311. So now when I say EECS3311, I'm talking about this object over here, right? This object. And then what about the prof? It's going to follow through this link over here. And they point to the same objects, don't you agree? That means over here, equals should be true. Okay? Guys, are we okay so far? Since we got sharing over here, so that means whenever we try to change the attribute value by any of the possible paths to the objects, it's going to be visible to all the other paths. Let's see some tests very quickly. So now, if I say over here, prof.setName over here to Jeff. So what am I trying to set over here? So prof over here is the object over here. Okay? The set name to be Jeff. That means rather than Jackie, it's going to be Jeff. Agree? So now, if I try to assert, for example, over here, first of all, I'm trying to make sure when I say EECS2030.getProf and EECS3311.getProf, I'm still following the two arrows, right? Still this arrow over here, which will be this object. And also when I say EECS3311.getProf, I'm following this arrow over here, I'm still getting the same objects. So they are pointing to the same objects. So that's why equal over here will be true. Agree? What about the next assertion? The next assertion over there, when I say .getProf and then .getName. Okay? Are you comfortable with this expression over here? When I say, I'll put it here. EECS2030.getProf and then .getName and then equals. It's quite a long expression over here. And then I say Jeff over there. Are you okay with that expression over there? You might have to write something as long as that for your lab number 3 or other exercises. Okay, just make sure you're okay. Let me explain this way. You start with the left-hand side. EECS2030, what's the type? Well, EECS2030 is of type course. So now you have course. So course, and then what's the type for course.getProf? GetProf will be just return the faculty, right? So that means after you say EECS2030.getProf, you will get a faculty objects. And then what about EECS2030.getProf.getName? What would that be? What would be the type for that? Well, faculty is over here, and then what about getName? It's going to return a string, right? So that means if I try to also expand that expression a little bit, so that means this .getName will give you a string. So a possible question for me could be, I simply can ask you over here, when I try to call this long expression here, what's going to be the version of the equals method I'll be calling? In this case, it would be the equals method from course, from faculty, or from something else. In this case. On a string class, right? Because all you have to figure out is, over here, you can see EECS2030 dot getProf dot getName. This expression over here is trying to infer over there is of type string. And string dot equals Jeff. That's why it makes sense. Okay, just make sure you're okay with that long expression there. Okay, are we okay so far? Okay, so now one more thing to get through it. So now what about the remaining part? The remaining part simply means we want to somehow reassign the things, the faculty being shared. Let's say we change the instructor. What we did so far, we just changed the name of the instructor. But now we want to change the instructor completely, not just the name. So what we're doing over here is, let's say over here, orange. So now let's say this line over here, we simply got another object here called prof2. And it is referring to a faculty objects, and then the name is simply just Jonathan. Let's see. Okay, it's a brand new faculty object. But after this line here, that faculty object has not been shared yet, just not yet. So what's going to happen if you look at this line here? EECS2030 setProf, and then prof2. What's going to happen here? How many arrows are we going to change? Just one, right? Are we going to change this arrow here or this arrow here? Number one or number two? Number two, right? Because if you look at that, you can see over here, the context object is EECS3311, which is referring to this object over here, right? You say that object setProf, which is going to change, rather than pointing to over here, is now going to point to this new faculty objects. So now, do we have sharing anymore? Not really, right? Used to be, but now since we redirect one of the courses instructor to be a different person, okay? Basically, that's what we're trying to do. So now, if you try to see this assertion over here, when I try to compare getProf over here, it will now be not equal to. Used to be equal to, but it's not equal to, right? Because we changed the arrow. And then if you try to check the instructor's name, so now for EECS2030, the prof is this object over here, has the name Jeff. On the other hand, if you look at what about EECS3311, it's now referring to this particular object over here, but now the prof is now pointing to this particular object. And the name is Jonathan over here. So that's why you see Jonathan here. Okay, it's quite a detailed trace over here, but any questions about this? Are we comfortable with that? So now we're only talking about one case for aggregation, which means a container contains only a single containee. So we have to worry about the more complicated case where the containee might be just an array of stuff. Okay, let's have a look for the second example, okay, and see how we can go from there. Okay, for the second one, we're going to, again, we are trying to draw a diagram, right? Trying to see how things are going to work. So we have a class called students over here, and also we have a class called course, and also we have a class called faculty. Okay, so these are the three classes we have. But now, the way we define the aggregation is a little bit different. Let me show you the diagram first, which you should also know how to read the diagram. Okay, this is how we do the simple case, where there's only a single containee. Okay, this we have already gone through. I want to show you this one. This is a new diagram we should know. Okay, have a look at that, and then I'm going to show you how you can read it. Let me just show you one case. I'll show you the case over here from student to course. Okay, let's see that case very quickly. So we have a class called students. We also have a class called course, right? Let's draw an arrow between them, so that means there's some aggregation relation. So now what we're trying to say is, if you look at the attribute declaration, for each student, we have the following attributes, like this. array list of course, CS. So you should be very familiar with the array list, right, from your lab number 3. So what does that mean? That means every student contains an attribute called CS. And CS is actually an array list of stuff, not just a single one. It's going to be a list of stuff. So that means this is how we can draw the diagram over here. A student has as many as we like, and star simply means 0 or more, because the list can be empty, right? Can be empty, can be size 1, can be size 2, etc. And then we say that student has as many courses as we like, let's say, as their courses called CS. That's why we put CS over here. And make sure it's aggregation, we put an empty diamond. Okay? So we simply put empty diamond over here, just empty. Okay? So whenever you see any diagram like this, first of all, you see empty diamond over here. That means it's aggregation. They can be sharing allowed. And second, if you see a star over here, that means you need to use a collection type for the attribute rather than a single reference type. Okay? That's how you see the difference between the two cases of aggregation. Any questions about the diagram here? Okay? Again, you don't have to know how to draw it, but you should know how to read it. Okay? So now let's yeah. So basically, we're saying, yeah, what you're trying to say is the student might share, two students might be taking the same course, right? So that's why the course can be shared. Remember, over here, student is a container. And course is a containee. And let's say Jim and Tom, they are both students, but they're classmates. They share the same course, right? Yeah. Okay, so now, let's try to trace the code quickly, okay? Let's try to see how you can visualize them, okay? So now, I would say the best way for you to practice yourself, you try to draw the diagram all the way until the assertion part. And then once you draw the diagram structure there, you want to judge to see whether each assertion should pass or fail, right? That could be one of the questions you can expect in the lab test, okay? Or exam. Okay, so now let's try to draw them. So what I will do is, I'll start with line number 1, okay? So now let's see how the object structure will be a little bit different. So what I would do is I will say P, I'll try to be careful. So P is pointing to a faculty objects. Each faculty over here has a name and has TE for teaching. It's going to be an array list of courses, right? So what I will draw is I'll draw something like this. So the name, N, and also TE. TE is teaching. And then N is going to be, I'll put Jackie over here. And then TE is going to be a link to some array list. Agree? And then over here, let's see, when we call the constructor for faculty over here, it's just going to create an empty list. Right? That's how you create an empty array list, right? That means after this particular line, after calling the constructor for faculty, TE is going to point to some empty list. This is how I'll just put empty like this. There's nothing there yet. Okay? What about the next line? When we go to the next line, we are creating a new student objects. So that means S is going to be a student. I'll say S is now pointing to a new student's objects over here. You know what? I'll try to draw that a little bit below. So S is a student objects over here. Students objects, and then it's going to be, again, let's see over here, student has an ID, okay, just like a name. And also the courses. I'll put the courses over here, and also the ID over here. So ID is Jin. And what about the courses? You can see from the constructor for students, we also try to create an empty array list. That means initially, the courses will also be just empty. So after these two lines, we have initialized P and S, right? Course and faculty and students. So now let's do the next two lines over here. So we got 2030 and we got 3311. EECS 2030, and over here we have a course object over here, right? That's what this line would do. And then we have course, And each course just has a title, just make it easy. Okay, I'll just draw one single attributes. Just title over here. So that's Advanced OOP 2030. And then for this line over here, we have EECS2030, which is pointing to another course object over here. And then the title is software design. I'll say SD for software design. Okay, so far so good? No sharing happened just yet, not yet, but we're going to set it up. Okay, so now let's do these two, which you're familiar with, right? How do I set a prof for the two courses? Let's do that first. Okay, so this one I'm going to skip the tracing detail. I will just draw it on the diagram. So EECS2030.setProf is going to be EECS2030.setProf. I think I'm missing some detail here. There should also be a prof over here, right? Sorry about that. I'll change the slide. There should be a prof attributes. Okay. So now let me just draw that very quickly. I think there should be. Okay, there should be a prof field over here, and also there should be a prof field over here. There should be, right? So I'll change the slides accordingly. Okay. So now, how do I say EECS2030.setProf? That means the follows. So now this prof over here for EECS2030 is now going to point to this object over here. Agree? And what about when EECS3311 is now has become the context objects? That means EECS3311, now the prof is now going to point to the same objects. That means I'm teaching two courses. Right? Good. Now, other than that, it's more like a bidirectional. Thinking this way logically. If I say the instructor for 2030, let's say this. If you say the instructor for 2030 and 3311 is me, that means symmetrically I'm teaching those two courses, right? So now how do I express that? Let's go to these two lines. Okay? When I say p.addTeaching, so the add method you're very familiar with, right? Just add to the array list. Let's do both at the same time. Okay, so now these two lines over here, when I say p.addTeaching, so p is this object over here. When I say addTeaching is simply just going to, addTeaching is over here. It's just going to call whatever teaching TE, which is the array list, .add, right? Just add something to it, okay? So when I say p.addTeaching, EECS2030, call by value, right? I'm going to skip the detail for call by value and just show you the diagram. So now, how are we going to update the diagram though? That means P being the context objects over here, and we are trying to add one course into it, just have one slot. And now it is going to point to 2030. Okay? And the next line, when I say the same context object P, .addTeaching, and then EECS3311, right? The same faculty member over here, but now we are adding one more course into the array list. And then it is now going to point to 3311. Okay? I will pause a little bit over here. So now, do we have any aliasing over here? Do we? We do, right? Let me have a little test for you. Let me give you a reference over here. If I say EECS 2030, I know that that's an address. Okay? I want to put something over here. What can that question mark be? What can that be? So EECS 2030 is pointing to this course objects over here. So the question is there any other path that's pointing to the same objects? Okay? TE at, TE.get one, right? Okay, I'll put it here. So that means prof.te.get position 1. Well, position 0. Yeah, starting with 0. Okay? Just something to strengthen your understanding. Okay, so now let's go further. How do I complete these two lines? When I say students.add course, so faculty can add teaching, just like a student can add course. So now, how do I do that? So now similarly, so now when I say S, which is students over here, the add course is over here, which will be adding to the CS, right? So now when I try to execute s.addCourse, I'm changing the CS attribute over here, right? So that will now become size 1. And that should really be pointing to 2030, like this. Similarly, when I try to execute this line, the same context objects, S, over here. So s.addCourse, and now it will be EECS2030, which is here. That means I have a second element added to the array list, and now it is pointing to this object here. You can see now we got 3 sets of arrows over here, red, pink, and blue, and also green as well. So now we got, again, even more aliasing, right? Okay, before I go to the assertion, let me ask you this. If I say the following, okay, again, EECS 2030, okay? EECS 2030 is pointing to this particular objects, right? The blue one. How many other ways can we actually refer to this particular object using aliasing? How many others? How many first? Good. Which 2? Can you give me the complete path? Complete. Starting with s.cs.get. 0 you meant. Yeah, remember indices start with 0. That's 1. And also similarly, you can also go from the p side, right? You can also p.te.get 0. Okay? They refer to the same object. So these are all equal. Okay, so far so good. So now I will leave these assertions to you. So these are checking exactly that. So you can see the assertion will become quite straightforward if you can draw the diagram like this. Okay, I'll stop here and then we'll continue next week for composition.